We'll look at what happens if we have a sum of functions for our forcing function in a non-homogeneous equation. Here's an example. So here we have two functions that are of the type that we see in the table in Dobrushkin. We've got one like this and then one of these. So what we need to do is include y particular, a term that looks like that and a term that looks like this. We're going to get a particular solution of this type. Now the great thing about linear equations is that we can treat each of these separately, which is to say that I could substitute this into the differential equation and figure out what the constants are or what they need to be in order to get that. And then, as a separate problem, substitute that into the differential equation, see what the constants need to be in order to get that. First, we want to check to see if we need to modify our basic rule. In order to do that, we need to find the roots of the characteristic equation, which are lambda equals 2 and lambda equals 1. We need to compare those with the control numbers for each of these functions. So the control number for this is sigma equals -1. Just looking in the table in Dobrushkin. And then for this one here, the control number is sigma equal 2i. So neither of those are roots of the characteristic equation. So our basic unmodified form for the particular solution should work. Again, leaving the computations up to you, I'm going to look and see what, what we get in Maple, see if we can make sense of it. So here looks like the homogeneous solution, and then we get the particular solution portion that gives us the sinusoids, and then we have the powers of x times e to the minus x. Now, as a modification, let's look what happens if I change this problem a little bit and make that a plus. Okay. Well, now the control number for that function is 1, and that is a root of the characteristic equation. So in our particular solution, I'll have to modify that it's a root of multiplicity 1, right? So I have to modify that portion of the particular solution by multiplying by an x. So I'm going to multiply by x here. The cosine part will stay the same. Cosine and sine part will stay the same. Times e to the positive x. We're going to need it like that, right? All right. Let's see how that goes. Well, here's our homogeneous solution again. We get an x e to the x, we get an x squared, and an x cubed e to the x.